A gigantic void could hold the key to solving one of the greatest mysteries of the universe. The James Webb Space Telescope has recently gathered crucial evidence confirming the so-called Hubble tension, a fundamental discrepancy in measurements of cosmic expansion. This discovery forces us to reconsider many of our beliefs about the structure and evolution of the universe, opening a new chapter in scientific exploration. Recent observations suggest that the universe may not only be continuously evolving but also far more complex and dynamic than previously thought. In other words, we are realizing that we know much less about the true nature of the cosmos than we believed. One of the most fascinating aspects emerging from these new observations is the presence of cosmic voids, enormous empty spaces stretching millions of light years, where visible matter is practically absent. These voids challenge Einstein's general relativity and traditional cosmological models, which predict a more uniform distribution of matter on a large scale. Their very existence prompts the question, what are we missing in our understanding of the universe? For example, the largest known void spans about 100 million light-years in diameter. If a beam of light were to travel across this immense region, it would take 100 million years to traverse it. Inside these voids, there is almost nothing, no stars, no galaxies, no gas, where hundreds or thousands of galaxies might otherwise be expected. These voids appear to be the opposite of dense cosmic filaments, the gigantic guidelines, threading through the universe where matter accumulates. But why do they exist? And more importantly, why are they so vast? Voids are not just spaces devoid of visible matter. They represent a theoretical problem and a significant challenge for scientists. According to traditional models, the universe should be isotropic and homogeneous, uniform in all directions and on a large scale. However, the presence of these voids contradicts this idea, suggesting that reality might be far more intricate. The Hubble tension is one of the most debated issues in modern cosmology. It refers to a discrepancy in measurements of the universe's expansion rate, the so-called Hubble constant, obtained through different methods. On one hand, observations of the cosmic microwave background, the residual glow of the Big Bang, indicate one value for the Hubble constant. On the other hand, measurements based on closer objects, such as standard candles, Cepheid variable stars or Type Ia supernovae, suggest a higher value. This discrepancy, which current models cannot explain, has forced scientists to hypothesize that there is something fundamental we do not yet understand about the universe. Edwin Hubble, the great astronomer who first described the universe's expansion, envisioned a uniform and regular cosmos. However, discoveries over recent decades and, more recently, observations from James Webb challenge this vision. Galaxies too ancient to exist so close to the Big Bang, structures too large for a young universe, and voids too vast to be random are just a few of the enigmas we are trying to solve. The homogeneity and isotropy of the universe are fundamental principles of modern cosmology. These concepts are based on the idea that, on a large scale, the universe appears uniform, much like an ocean that, despite waves and currents, distributes itself evenly. However, cosmic voids are like holes in this ocean, anomalies that should not exist according to our models. What created them? Are they truly empty, or do they contain something invisible to our instruments? Theories to explain cosmic voids range from well-established scientific hypotheses to bold speculations. Some researchers propose that voids could result from collisions between parallel universes, remnants of clashes in a hypothetical multiverse. In this scenario, voids would be cosmic scars, evidence of a past far more expansive and complex than we can imagine. Other scientists suggest the possibility of advanced civilizations manipulating matter and energy on cosmic scales. A theory derived from the work of Russian astrophysicist Nikolai Kardashev posits that highly advanced civilizations could obscure entire galaxies to harness their energy. If true, cosmic voids might be the result of such activities, zones where matter has been removed or altered for purposes still unknown to us. There is also the possibility that voids contain dark matter or dark energy in unusual configurations, invisible to our current instruments. This explanation, while less exotic, is equally intriguing, as it would compel us to revise our theories about how the universe operates on large scales. The James Webb Space Telescope represents a quantum leap in our ability to observe the universe. Since its launch, it has revolutionized our understanding of the cosmos, revealing primordial galaxies, incredibly complex structures, and, of course, voids. Its observations have already challenged many established ideas, but we are only at the beginning. The universe appears to be much larger, older, and more complex than we had imagined. The implications of these discoveries are profound. They could lead to a complete revision of modern cosmology and even new laws of physics. Perhaps, as some scientists suggest, we are only scratching the surface of what there is to know about the universe. Thank you for watching. Leave a like, subscribe to the channel, and activate the notification bell to not miss future videos.